Hi guys, I'm Alessandro Cangelosi and that's a new tutorial for TheLab tutorial library from Projects VFX School. Today I'd like to start a new series of tutorial, and this time we're going to talk about Houdini. You know, Houdini is a really complete and complex and powerful software for visual effects and 3D computer graphics and animation. It's really complete. You can do everything inside Houdini, but it is really well known for its visual effects feature. We are talking about particles, we are talking about dynamic, destruction, fluid dynamic, and fire, explosion, smoke, and a lot of stuff. So the main problem with Houdini is that every user will think that it's a really complex software, and maybe that you can be scared to start playing with the software because it is really a different way of thinking. It is a node-based environment. It is completely procedural. Maybe you have to go more in depth using scripting, visual programming, and stuff like that. By the way, my main idea, my purpose is to show how to use Houdini to create some visual effects for artists. So we'll try to find the most simple way to start playing with the software, start creating really amazing stuff, and then we'll move step by step, more in depth, with upcoming courses at Projects VFX School. So this is just the beginning to start talking about the software, and I hope you will be able to start playing with the software and create some stuff. Inside Houdini, you have all the pieces to create your own visual effects setup. This time, this lesson is a brief introduction to fluid dynamic, and we're going to talk about water tank and splashes. And here inside the user interface, we have in the shelves, we have some tools that are able to create complete setup to create some stuff. Like, for example, you see oceans, we have particle fluids, we have the grain, we have cloth, we have collision particles, we have a lot of stuff. So main idea is to start from the shelf and understanding how the software works, how to use the user interface, and how to manage stuff inside Houdini. We are going to use the release 17.5, and our first idea is to start playing with a fluid dynamic. So this is the 3D view. To move inside the 3D view, remember that we can use the middle mouse button to make the pan, and Alt key and left mouse button to make the orbit, and Alt key and right mouse button to make the zoom. So this is just the beginning to start playing with the scene. The measure is in the unit measure is in meter. So for example, this one is 1 meter, 2 meters, etc., etc. Here we have the parameters. Here we can find the attributes, and here we have the node interface. You see that we have different panels, but for the moment let's play just in the simplest way. If you press here and drag, you are able to scale the interface, so we can adapt as we like. Here, for example, you can see that we have the possibility to drag, or we have an arrow to the top and to the left and to the bottom, sorry. So if we press to top, we are going to maximize the node-based interface. This is the context. A scene inside Houdini is divided in context. You see the channel, images, materials, objects, output. Shop, this is the shader operator, and then that's the main area. I think you read something about VOP, POP, DOP, and stuff like that. So we are going to see what we are talking about, and we are talking about operators. So don't worry about it. Objects is the main context. Here we can create our scene. To create our scene, we are going to use a simple preset from the shelf. So we go inside the ocean, and you see that we have many presets here to create stuff. So the first one we are going to create is the wave tank. Wave tank is going to create a tank, so a fluid container, and it's going to add a spectrum animation for ocean waves. So it's really nice. So let's press over the wave tank, and then you see that now it is asking for something. It says select the object to follow and press enter to complete. In this case, for example, if we have, let's say, a ship, we can have the container following the ship to create the fluid dynamic. If we have no objects and we like to create a static tank, you see we can press enter with the no object selected to continue press with static tank. So let's press enter key. You see that now we have a box, and this is a box. We can press where we like to create the box, and it is going to create everything needed to create a water tank setup. Okay, so you see that actually we are inside the wave tank initial object. Let's go back to objects. We can zoom back. To zoom everything, you can press space A. This is zoom to everything. If you press space F, it is zoom to the selection. So you see we have something. This a container. We see the particles, so we have everything needed. You see that we have the color. We have something that is ready to be used. Here we have some object that was created by the shelf. Inside the context here, the node-based user interface, you can use the same shortcut to move. So middle mouse to make the pan, and then Alt key and right mouse button to make the zoom. And the nice thing is that you can also press the L key to layout. So if you have stuff all around, the layout will be automatically created. You can select a node to move it. You see that we have a snap with some lines that show what we are doing. So the main idea is that we have different stuff. Here, for example, you see DOP. DOP is dynamic operator. So here we have everything related to the dynamic. Then we have some geometry. You see that over the node we have a name, something that say which kind of node we are going to use. So this is a geometry, and same for this one and the other one. First of all, let's select everything with the mouse and press here to create a network box. Then we can scale the network box, and now the network box is a container for everything about the water tank. Double click and we can write water tank. Okay, if we like to change the color, you can press the C key. You see that we have a color palette. Let's go to use, for example, this one. Okay, if you press again C key, you go to remove the color palette. Nice, we have the basic simulation. So here we have the dynamic system. Actually, you see that we have a blue label over a node, and this one is to make it visible or not. So actually we have the water tank fluid, that's this one, and the water tank fluid interior. It is something like the water volume. So this is visible just in rendering, and this one is visible in viewport. Okay. Then we have the water tank fluid extended. This one is to extend the simulation out of the tank. So here we can have wave created by the spectrum waveform, and here we have the fluid dynamic. Wave tank initial contains some initial information about the water tank. So let's go to save the scene. So save as, let's go in our folder. So let's create a new folder. This is August 2019, and this is Houdini for Artists. Okay, let's go to create a name, and this one is water tank 01. Okay, it is saved. So everything is really, but by the way, actually we have no more parameters here. If you like to have the parameters, you can press the P key over the node view. So you see the P key give us the parameter. It can be scaled, so don't worry about it. You can find the proportion to see everything inside the view. Let's scale a little bit the view. Okay, so let's press P to close the parameter, and let's give some idea about what we have here. Double click over water tank sim. That's the simulator. So this is everything about the dynamics. So you see we have a flip object, that's the wave tank. Then we have the flip solver, that's the main solver. Then we have some nodes and some dynamic information like the gravity force. If you go, for example, inside the flip solver, you can press and double click, and this one is the solver. So you see, this is important because it is really complex, but it means that you can be able to create your own custom flip solver if you like, and on the other side you are able to go inside the actual solver and change stuff to create custom solver. So this is interesting. By the way, it is a really complex thing, so actually we don't take care about it. So let's go back to the water tank. Then back here you see that we have the wave tank initial. Here we have all the information about the creation of the wave tank, and for example here we have some stuff that are more interesting if we go to move it. By the way, we are going to talk about some nodes in a few. This is the interior renderer, and actually it's really simple. By the way, we don't take care about it. The wave tank fluid is something that is going to create the fluid for the rendering, so it is really important. And you see this one is visible because it will be rendered. And then here we have the extension. It is a really complex stuff. Let's press L to create the layout. By the way, for Houdini, this is a good layout, so you have to move it manually to create a more clear layout. By the way, this one is a little bit more complex, so we are going to talk about it in coming lesson. So the important thing is that actually this one is completely working. So if we go here and we press play, you see that it's starting to simulate, and you see that here we have a blue bar. The blue bar means that we have a cache. The cache is going to work with the memory, so actually we are using the memory. If we have not enough memory over the inside our workstation, obviously we'll have, for example, here we have the maximum memory, so it will continue to cache, removing previous frames. By the way, this one is really simple, so it is simple to be cached. You see that we have a flip simulation, and this flip simulation is working with a spectrum animation to have waves. The resolution is really low, I have to say. We have particles, and the distance between particles is really, really high. You see that if we go near the water, we have a really poor quality. By the way, if we are really far, it is not bad. So it depends on the point of view you have. By the way, this is a cache, so actually, obviously it works in real time. If we select the wave tank, here we have the information about this simulation. If we like to remove this simulation, we can press reset simulation. Another important thing is the substeps. Here we have one substeps. If you have really fast moving objects inside the water, it would be better to have a little bit higher substeps like 2 or maybe 3 and stuff like that. Here inside cache, we have the information about the caching in memory. You see that we have cache simulation, it is set to on, and the cache memory is 5 gigabytes. If you like to have more memory for real-time caching, you have to raise up this value. By the way, let's go in the initial. Okay, here it is a little bit more complex. By the way, for the moment, let's talk about just 2 things. First one is the wave tank. This one is the tank, you see is the container. We have 2 possibilities. We can use the handle to scale it. So you see that we can scale it, we can scale over the top, over the back, over the left and right. Obviously, we scale it a little bit, so we lose the cache because we had the simulation ready, so we changed something and simulation needs to be redone. At the other side, just to let you know, if you move, for example, here, obviously it needs to cook everything, so it can take a little bit. If you press ESC, it stops, and if you simulate something, you have it. By the way, obviously don't take care about this kind of error, it is just because I stopped the simulation. Here you see that we have the auto update. If we go here and we set to manual, if we go here, you see that nothing happens. In this way, we are going to update manually, so we can play with everything, animate, parameters, and stuff like that, and then we can go back and launch again the simulation. If you like to update, obviously you can press this button. Let's go back to auto update. Okay, when you see parameters like this one, so you see the green color, it means that there is something related to this parameter, like, for example, a connection with another parameter, or, for example, an expression. To know something about it, you can press and click over the parameter name. So you see that here we have the complete written parameter. It is really complex, so let's go on another one that is more simple. This time it's more simple. It means that it is a channel. It is related to animation and controlling the parameters. And you see that this one is linked to wave tank sim, wave tank particle separation. It means that if we go in wave tank sim and then we go in wave tank, we have here this parameter, particle separation. So it means that if we change this one, automatically it will change this one. Okay, so you see it is set in the same way, and the same is for the other. So we have the possibility to disconnect if needed. By the way, we'll see how to play with it step by step. So other things that can be useful at the moment is, for example, this one. And we are talking about the ocean spectrum. The ocean spectrum is the animation. This one is able to control the animation of the waves. If we press over the ocean preview, we see how it works. Let's try to understand how this is playing. You know that here we have the ocean spectrum node, and this one is able to create waves. It is really complex, and we'll talk about it step by step. Here we have a merge spectra. This is a merge node. It is here because if we like, we can have different spectrum and everything can be merged in the same wave spectrum. Then we have this one that is going to the wave tank. In this way, you see it is connected to the wave tank ocean spectrum to control the water animation in the flip fluid. On the other side, it is going inside an ocean preview. This node is able to create a preview of the waves, and it's using as the first input, this one is the geometry, you can read it here, geometry to the form, and it is going to use a grid. If we press here, we see just the grid. If we press here, we see the effects. So how the ocean spectrum is deforming the grid preview. So if you like to see how it is playing, you see that we see the waves over this one, and then obviously it is moving forward. It is not so fast because it needs to simulate also the fluids. By the way, it is useful because for example, if you go here and we say let's say that we change the direction of the waves, so 45 degree, you see that everything is changing in real time. We can change, for example, the sharpness to have higher crest, you see more precise crest over the waves, and we have a lot of stuff here. So actually it's not important, so we'll talk about it in coming lesson. By the way, let's go back to the water. Okay, so obviously there are many things we have to talk about, so don't take care about it. Okay, so guys, we have here a lot of things inside Houdini, but actually I'd like just to let you know how you can start creating something and how you can play with some basic value and parameters, trying to understand how it is working and playing with it. So if you like to remove the ocean preview, you have just to set to display this one. So we are back to the previous situation, and we can go back here, and obviously now the simulation will be a little bit more interesting because we have higher waves, so it is a little bit more interesting. So let's stop this one. Okay, so that's the result. So if you go, let's see here, and we select this one, we can get to have a better resolution. Actually it is 15 centimeters, this one, because it is in meter. So if we go, for example, to 0.05, we go to a scale of 5 centimeters. So you see that it will be able to create something more complex. Obviously, if we are really near the water plane, it's still not good. But at this distance, it can work in a really nice way. Again, also in this area, in the water simulation here and the DOP, we have a lot of information. Inside the flip solver here we have a lot of interesting stuff related to the time scale, for example the sub steps, and then we have some information about the particle motion, the volume motion, and then we have the simulation of the narrow band. The narrow band is this really nice technology that give you the possibility to have just a band of water, and it will just to create and simulate particles for water simulation down the water plane just when needed. So you see, this is the tool. If we set this one to off, actually it is set to on due to the preset, but you can remove it. Changing the setup is not a problem. In other ways, you will be able to remove the option, and obviously it will take more memory, but it depends on the case. So inside the particle motion, you see that we have a lot of information about the water, about the particles, and then the volume motion you have information about the collision, the viscosity, some information about the density, the tension. You see a lot of things that actually are not used. So this is really basic. I mean, again, this the simplest way to simulate something like that. You see that now if we try to simulate, obviously it is really slower than before. This workstation is not so powerful because it is just a dual Xeon E5 2687W, but it is the step 0, so it's the first one. Actually, we are working with 16 core and 32 threads, and we have 64 gigabytes of RAM, so it is not bad. but it is not the best solution to create complex stuff at a really high speed. By the way, you see that it's starting to create something interesting because we have more details, so we can have an higher quality simulation. Now we can see maybe when the water here over the crest will splash over the water. Obviously you will have a really nice simulation, and you know, because the spectrum is just a guide. On the other side we are creating the simulation using the fluid, so one is a guide and the other one is for the simulation. So let's stop this one and let's see what it's doing. Okay, obviously it is slower to be also played because you have more particles, but you see that the quality is really better, and it is able to start playing with a really some nice information. By the way, actually we are still talking about the meshes and stuff like that, so actually we are still talking just about the water tank. So let's imagine that we like to make a splash. If we like to make a splash, maybe the first thing we can do is to go inside the wave tank, and we can have a lower waves. To do something like that, we can go directly without the need to play with the wave speed that is here inside the wind. We can go inside the amplitude and we can scale with an artistic approach the wave. Actually, you see it is related to the grid size, so it is related to the resolution here, and it is a fraction. So if we like to have a lower wave, we can, for example, multiply by 5. So you see that it's really low. So we have a little bit of movements, but nothing so big. Again, to make some tests here, we can go back to 15, and the simulation will be really simple. You see, we have a little bit of movement, but nothing special. Okay, so nice. Let's imagine that we like to make a splash, so we need a collision with a mesh. So we can go inside the object and create a new context. So the tab key is able to open the tab menu. We can also press the right mouse button, it's the same. We go inside the geometry and we go to create a geometry node. With the geometry node we are going to add a mesh inside the scene. So let's say this one is, let's say, collision mesh. If you use the space, you see that it's going to use the syntax here. Okay, mesh, double click over it and you see that it's empty because we have no mesh. Tab key, let's try it, sphere, and you see that we have a sphere mesh. Okay, here we have the sphere. Let's call it sphere, and inside the panel we can decide which kind of primitive it is. This one is a primitive, so it's an internal mesh of Houdini. We can change to, for example, polygon mesh, and let's leave the full value here. Then I like to move it and then make it falling down, but actually we're going to do it manually. Okay, so tab key, transform, and this is a node to move. So let's say y move. We are going to use this node to move the mesh over the y-axis. Let's set to display this one. You can move it using, for example, the handle, so you can move it in this way, you see, or you can just set the value here, or if you press the middle mouse button, you see that we have this scroll menu, and you can move here to move by dot 1. If you go here, you can move by 1. If you go here by 10, So you see it's really nice here. It is 0, 1. So it is a really nice way to move stuff. Let's go to maybe 6. So it is 6 meters. We need to create a key here. By the way, let's go there and let's set to off the fluid back in the collision. Okay, to create a key here, you can just press the Alt key and click over the value. You see that now it's green, and here you see that we have a key. If we press here, you see that we have the possibility to set to the auto key. And this way it will work like the auto key, for example, in 3ds Max. So if you change something, it will be an animation. By the way, let's stay with this way to manage the stuff. So let's go at frame, for example, 10. And let's move it down the water. And again, let's press Alt key and click. So actually, we have the animation. If you like to see in the cube editor the value, you have to press the Shift key and click. And then you see that we have the graph here. We can zoom on this way, and then we can, for example, select both and say that we like to have a linear, and close. Let's save. Okay, so we have the right animation, and now we can go back and set to on this one. Okay, now we have the animation, but we have no collision, so we have to say that this mesh is a collision mesh. You can do it manually, but again, we are trying to understand the simplest way to manage stuff. So my main idea is to use the shells actually. So inside this shell, you see that we have collision. We have various stuff, and for example, we have static objects, deforming objects, and we have the possibility to, in this case, actually we have no deformation, so the vertices will not change position, but just the animation. So we can use also the static objects and then asking to have the animation. By the way, maybe we can change the animation later. So let's go for the deforming objects. So we have this one selected, we say deforming. And you see that here it says select objects for the deforming objects. So we select this one and then press enter. Okay, something is done. So if we go inside collision, you see that now we have more stuff. Until this one, we have created the stuff manually. Then we have a collision source. And this is a collision nodes to create the collision and stuff like you see the voxel size to create the collision, so something that needs to be done to create the collision. Then we have a node that is going to create some attributes to be linked with a DOP to create the animation and the simulation. Then here we have the possibility to cache the animation if we like. So we have a file cache, and this node is able to output a cache file just for that node. Just to let you know that here, for example, in the file cache, we have this string for the file. The string HIP is the folder where we have the file. So it's this one where we have the water tank underscore 01 file. Then we have the folder geo that will be created by default if it's not present. And then we have the string hip name. This is the name of the node. So sorry, the name of the scene. So it's this one, water tank underscore 01. Then we have dot 0 has, and then we have the frame, and we have the file format, and etc. etc. So it is a little bit complex at the beginning, but we'll see step by step to understand how it is possible to create some information about the caches, because we have a lot of caches around. So we'll see more in depth later. Let's go in the wave tank scene. This is the DOP, and you see that something is happening there. Let's press L key, so we have a new layout. let's move maybe this one here. Okay, you see that now inside the merge we have the flip solver with a water tank inside, and then we have the collision mesh, then we have a merge, and inside this merge we are going to put all the meshes that needs to have collision and interaction with a flip fluid. Then we have a static solver that is used to create the simulation that is merging inside the simulation. This is a simulation where we have collision objects and flip fluid. Okay, so if we start this one, you see that it's connected in any way to the file, to the object. You see that, for example, here we have object path, obj, that is this context, obj, and then we have collision mesh. If we press this one, you see that we go directly here. If we press here, you see that this is the SOP. So this is a connection to the surface, and we press here, you see that it goes here. Okay, so the collision source. So that's how it works. You're able to see the connection, and you're able to move where we need to do it. Other things is that actually obviously everything starts at the beginning, at the frame 1. We have some physical information about this object, we have some information about the collision, we have the possibility, for example, to see the guide. So actually it's using a guide. This one is in blue, so we'll see more in depth when we have some more complex collision, how it works. Here we have another connection, is the proxy volume, is the VDB output that we had inside here. So it works with a cache if needed. If there is no cache, obviously it will use it step by step during the animation. We have here the possibility to control the rigid body solver or the bullet data to make more complex and more precise simulation. So actually it works. So if we go here and we say play, you see that we have the simulation. So we have the collision, we have the splash, and we have the water deformation. Okay, and then obviously the water will fall down to create the splashes. This is really basic, but you see that it is working. So we have something in a really fast way. Let's wait to have a little bit more frame. The visualization is, you see, we have the blue, we have a brighter blue, or maybe we can have the white, and actually the based on the speed. So let's stop. If we see, this is the simulation actually. It is poor about the detail because we have a really low quality scaling, but if we go here and we check it, maybe it is a little bit more visible. Okay, so if you like to create a flipbook, so I mean a preview, you have this button. You can press with the right mouse button to open the settings. Inside the settings, we can have the possibility to open the flipbook inside the mplay. The mplay is a RAM player coming with Houdini. You can close this one, and this one is a variable. You see this is string rf start and string rfn, so the start frame and the end frame. By the way, we can write, for example, here 1, and let's say maybe 64, and the step is 1. Then we have to choose the output. Let's select this one. We go in our heap folder, this one where we have our mesh, our scene. Let's write a new folder, and we go to write water tank underscore preview dot string f4, and it means that it's going to add the number frame with 4 digits, and then, for example, JPEG, and start. Okay, And it's done. So if we go inside the right folder, so it means to go inside here, August, Houdini, we have preview, and you see that we have it. So we can press, double click. It will take a little bit of time to load the DJB. Okay, and we have the preview. Okay, so you see it's really simple, but it is working. Okay, so just to give you an example, if we like to have, for example, more speed to the water interaction, we can go inside the water tank, the water sim, flip solver, and we have, and the volume, we can, for example, go inside collision and say that the velocity scale is 2. Then we can again play, and we'll have, you see it is more white because the speed of the collision is higher. Obviously we have no simulation out of the tank, so this is just something more similar to a really bigger objects or something faster that is colliding with the water. So see, maybe this one is amazing. So by the way, let's go inside the initial, and let's go to change the water tank to give more space. So let's move this one higher. Obviously it will need more memory, because if we move the mouse over this node and press over the high, you see that here we have a lot of information about the model, and actually we have just 63,000 particles, but we have 10,000 voxel actually. So we have a lot of voxel, and if we go with a lower scale, we'll have a lot of memory needed to simulate this one. Obviously in this case, if we try to simulate, it will work perfectly, and I think that the scale now is nice. So maybe it is still cut, maybe, I'm not sure, but you know, it is working in a better way, and then it is going down. Obviously we can take care about all the parameters here, because this one is really not nice. By the way, you see that's the collision. So I think we can do two things. First of all, let's go here and let's say that the speed maybe is 1.5, and let's simulate again some frames. Then, you know, we are talking about really fast moving objects, so we can, for example, thinking to select this one and give another substeps. So we are talking about 2 substeps for each frame, just because we have a really fast moving object. In this way it will work a little bit better for sure. You see that it is working nicely. I think it is not so high as before. Let's stop. Okay, we have a little bit less energy, but on the other side we can do something else. Let's go back here and let's say that we have 2, and then we go to add something. We go to add a force. So the really nice thing is that inside the flip solver we can use the pop dynamics forces. The pop is the particle operator. So we have a class of stuff here. Let's press the tab, you see that we have pops, and here we have a lot of tools used by the particles inside Houdini. We can use, for example, a pop force, this one, the pop drag. This is a drag force. So actually, let's go to call this one drag. Okay. This one needs to be connected to the flip solver. You see that here we have the fluid to solve, that is this one. Then we have the particle velocity, and here is where we can merge the particle forces. Then we have volume velocity, and then we have the sourcing. So we have here the possibility to put more liquids inside the flip solver. So here we have the container, and here we can have fluids that put water, for example, inside this tank. Let's connect this one. And this one, if we select the nodes, you see that we have air resistance 1. We can set, for example, to 10, so it's really a really high value. The activation is the frame, so we can, for example, animate when we like to have a force just animating the activation frame. By the way, let's leave it active by default. So now we have gained the high energy we had before, but we have also the drag, and it is really high. So you see that we have no splashes, and that's just because the air resistance is really high. So let's see what happens if we try to lower this value. Okay, you see that we have some white, but we have still no splashes. So let's go back to, for example, 1, and you see that we have also some parameters to add a wind speed. We have more white, and you see that the crown is starting to be simulated, but it is still really poor. So I think we can go lower, so just a little bit of air resistance. When you have the simulation here and you have a frame that is higher than the first one, if you change something, now the cache bar is not blue but it is orange, just to let you know that the cache needs to be resimulated. So let's go back, let's set to play again. Okay, it is starting to work in a better way. So actually we have the air resistance, so we have a little bit of drag, and we have the energy as before. So this is how it is working. So it is maybe simulating in a really better way than before. By the way, you know, you can manage the drag force and the collision energy to find the best compromise. And remember that we never set other water parameters here to play, for example, with this value. You see that the drag is a little bit still high, I think. By the way, we can think about it later. You see that now we have a new crown, and we have a more complex simulation just because we are using 2 steps in the DOP. Okay, nice. That's the actual result. We can see from another point of view. Okay. Let's go in the water fluid, and actually we see just the DOP input. Let's go in the surface view. Actually it is set to mesh. You see compressed fluid surface and particles. So it is compressing the simulation data and it is showing the particles. If we like to see what the particles are showing, it's the velocity. We have the possibility to have a velocity range. So for example, where we have we have a lot of white here. We can say, for example, that the speed range is higher, so actually it's not able to go to white, so maybe just at the beginning you see here, and then we have always the bluish color. By the way, we have the possibility also to decide to see the vorticity of the water, and actually we are not simulating vortices, so actually we have no information, also because we are not transferring information about the vortex. So for the moment we have to stay with the velocity, so that's what we see. By the way, let's go back here. Let's see, because we are going to use this one in many lessons. So now you know if you like to have a more complex simulation, we have to go here, select a wave tank container, and say, for example, that we like to have 10 centimeters for the scaling. And again, if we go to simulate, it will work better than the previous one. Obviously it will be not the best one, but it's better than before. And then the other way, we have the possibility to add also spray, mist and foam that actually are not visible because we have no simulation about it. So obviously the simulation can be a little bit different than before. By the way, it's not so slow. Let's see what happened with some frames simulated. When the water will splash down the water tank container. Okay, let's stop it. And you see that. That's really interesting. So this one is just for the water. Obviously we have to play with value, trying to understand how to manage the stuff here. So it is just, remember, it is just an introduction. So let's go back to 15. So if we like to add, for example, the foam and the spray and stuff like that, we have something inside the ocean. We have the white water. The white water is able to simulate all this stuff. How to play with it? We can press white water, and actually, it is asking which is the fluids that needs to be used. In this case, you have to select the wave tank and then press enter. So it just created a white water simulation that is similar to the other one. So we can pick the stuff here. You see that some nodes are similar. We have a dot to simulate the dynamics of the water. We have the search to understand where the white water needs to be done, and then something to make the rendering. Let's select this node. Again, we go to create the network. We have to select here and say that this one is blue, is violet, and let's say white water, and save. Okay, it is ready. Now what happened? If we go here and we try to simulate, we'll have both simulation. Obviously the workflow is different because usually you make some caches for example for the water, and then you go to play with the other stuff like the particles. And you see that here we have something, and we are talking about the foam and the spray. So it is an additional simulation. Okay. So obviously it is solving two things in the same time. So it's going to create a simulation for the water, and then it's going to make the simulation for the splashes. We have many parameters to control also in the splashes, but we are talking about the basic stuff related to foam generation, sprite generation, and stuff like that. So let's wait maybe for some frames just to see how it looks, how it plays. Okay, you see that we have a lot of information here. Let's wait to the stop. Okay, first of all, we see that there is a container that is smaller than the other one, and we have collision between the sprite particles here. Okay, we are here and we see the particles here. We have a lot of information about the particles. By the way, don't take care about all the stuff you see here because it is a little complex. So you see in black we have the splashes, and actually it is creating foam and splashes. So we have the foam over the water, and we have also the splashes. We have also bubbles because down the water it is creating also the bubbles. So it's going to create a lot of information and a lot of stuff. So it was just an introduction, just to try to understand how to play with shelves to create some basic setup for creating a splash. In the next part, we're going to talk about some more nodes. We'll talk about a different way to create a splash, and then we'll talk about how to create a more complex setup and how to manage some data, some caching information, and how to move to the rendering. So it will take some videos because you know, it's really complex, but we'll try to use the simplest way to understand how to play with all this stuff. So thanks for watching, and we'll see you soon for new Houdini for Artists tutorial on the TheLab Patreon and video on demand, Vimeo on demand videos. Bye bye and thanks.